Hey everybody, this is Mr. Ainsworth. We're going to get into a full review of what we've done so far this year in section 9.1 from the beginning of the year till now. So let's start off with the first 15 Fibonacci numbers. Let's start off with the two seeds, okay? And the Fibonacci numbers start with the two seeds, 1 and 1. All right, remember that F1 and F2 here are called seeds. They're the starting values. All right, and then you take them and you add them together to get to the next one. So 1 plus 1 is 2. So the third Fibonacci number is 2. All right, 1 plus 2 is 3. 2 plus 3 is 5. So the fifth Fibonacci number is 5. Well, 3 plus 5 is 8. 5 and 8 is 13. 8 plus 13, again, you just add the 2 to get to the next one, is 21. 13 and 21 is 34. 21 plus 34 is 55. That's your 10th Fibonacci number. 34 plus 55 is 89. All right, and then 55 and 89 is 144. And then you get 233, and then 377, and then add 233 and 377 is 610. That's your 15th Fibonacci number. So you start off by writing down the first 15 Fibonacci numbers, and then you use them throughout the exercises, okay? And that's why I put it there in number 1. So here we go. So 6 times the fifth Fibonacci number. So 6 times 8, 48. Here you have negative 4 times F12, the 12th one, which is 144. All right, plus 5 times the 10th one, which is 55. All right, if you want to use your calculator, cool. All right, you enter in negative 4 times 144. All right, then you want to add 5 times 55, so 5 times 55. On these calculators here, you just enter in directly, and you get negative 301. All right, next one. We get F3, which is 2, so 2 to the 7th minus f of F6. Well, F6 is 8, so really this is f of F8. Excuse me, f of 8, which happens to be 21. So this is 2 to the 7th minus 21. So 2 to the 7th, what is that? Well, let's do it the quick way. 2 to the 7th power. All right, you can think 2 times 2, and you just keep on doubling it and do that 7 times. So 2, 4, 8, 16, 32, 64, 128. That's 2 to the 7th. So, and then you got to subtract F8, which is 21. So minus 21, and you get 107. So 128 minus 21 is 107. There you go. Okay. Next one, F9. There we go. F9 is 34, so this is 34 minus F10, which is 55. All right, divided by F11, which is 89. Well, 55 minus 34 minus 55, that'd be 21, but it's negative. Okay, so negative 21 89ths. F4 to the F5 power. So F4 is 3, so this is 3 to the F5 fifth power. And that looks like 243, I think. So 3 to the fifth power, 243. Okay, and last one, F8, which is 21. All right, minus 3 times F4, so it's 3 times 3 is 9, so minus 9 raised to the F3, so that's squared. Okay, and so that right there, well, let me just write it a little bit bigger. So 21 minus 9 squared. Okay, that's 11 squared, or 121. Okay? All right. So we're just stepping it out and do what we normally do in here. Okay. What's the nth Fibonacci number? Well, how do you find it? Explicitly. Well, you can do it recursively or explicitly. So Benet's formula here, let's write down Benet. Benet's formula is f sub n is equal to 1 plus the square root of 5 divided by 2 to the nth power minus 1 minus the square root of 5 divided by 2 to the nth power, all divided by root 5. That's the explicit formula. The recursive one, f sub n is equal to f sub n minus 2 plus f sub n minus 1. So this is the recursive definition. All right, recursive rule. And this is the explicit rule. So if you don't know the previous two terms, you use Benet's formula. If you know the two previous terms, you just use the recursive definition. Okay, now how do you write the sum? Write each of these numbers as a sum, all right, of distinct, which means different, all right, Fibonacci numbers. So we're going to use these up here, these numbers in red, these Fibonacci numbers. And I see that 233 plus 5 more is 238. So there you go. So 233 plus 5 more equals 238. It's this number here and that number there. It's the 5th and 13th Fibonacci numbers. That's all you have to do. 26 is 21 plus 5. So it's the 8th Fibonacci and the 5th Fibonacci number there. 10 is these three added together. Again, they have to be different because it says distinct. Okay, you have to understand that. That means different. So 2 plus 3 plus 5. 2 plus 3 plus 5. 29. Well, let me see. That's 21 plus 8. And 37. Well, that's 34 plus 3. All right. The sum, you have to write them as the sum, that's a key word, of distinct, different Fibonacci numbers. All right, number 5, quadratic time. So A, B, and C. So A is equal to 1. It's the coefficient right here. B is -1, and C is -1. So A is 1, B -1, C is -1. So X is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So x is equal to negative of -1 plus or minus the square root of -1 squared minus 4 times a times c divided by 2 times a. And when you simplify this, you get -1 plus or minus root 5, all divided by 2. All right, why? Because right here, that's 1. This is all 1 right here. -1 squared is 1. And this part right here, I see a double negative right here. Let me do it in red right here. Boom, boom, right there. So it's 1 plus 4, which gives you a total of 5. Okay, if you want to write them separately, 1 plus the rad 5 divided by 2, 1 minus the rad 5 divided by 2. Two solutions there. Okay, so show how to find each Fibonacci number. This has been A's. Okay, so I want you guys to use that. That's up here. All right, Benet's formula right here, this fancy one that we use with the calculator. So we're going to show how to set it up first. So here we go. So 1 plus square root of 5 divided by 2 to the 24th minus 1 minus the square root of 5 divided by 2 to the 24th power divided by root 5. And we do this whole thing on the calculator. So let's get it going here. So clear it out. And so double up on the parentheses because you have to put the parentheses around the numerator. So you're going to have to double up on your parentheses if you do the whole thing on the calculator. 1 plus the square root of 5. All right, I have to get out of the root, close it off, divide by 2, close it off and take it to the 24th power. Then get out of the exponent, minus, double up on the left, 1 minus the square root of 5. Get out of the root, close it off, divide by 2, close it off again and take it to the 24th. Now that's the entire numerator of Benet's equation. I'm going to take that result, I'm going to divide it by root 5. And I get 46,368. Let me just double check that. 46,368. There you go. All right, now let me do something really cool here. Okay, so this is what I just did on the calculator right here. All right, and that's how I generated the result. Okay, you do everything on the TI-84. The same thing on the next one here, but you replace the exponent instead of 24. I'm talking about the exponents here. You replace it with 35. So let's do it. So here we go. One more time. So 1 plus the square root of 5. Okay, get out of the root, close it off, divide by 2. Close it off and take it to the 35th power now. Okay, get out of the exponent and repeat it. Minus, double up on the left, 1 minus root 5 now. All right, get out of the root, close it off, divide by 2. Close it off and take it to the 35th power. That's the entire numerator. All right, divided by root 5. And you get, look at that number there. Let me capture this here. And there we go. So F5 is equal to this number here, which is, I think, 9,227,465. That's the 35th Fibonacci number. So let me just double check that. Yep, there we go. That's correct. And then now the 42nd. So here we go. Let's do it one more time. So I'm going to press clear this time. So double up. You know what? Actually, I'm going to do a step-by-step approach. No, I'm going to do the same thing. I'll just keep it going here. What the heck? So I enter this in. That's incorrect. Let me start over. You got to get out of the root, then close it off, divide by 2, close it off, and take it to the 42nd power now, because we're trying to find the 42nd Fibonacci number. So minus, there we go, that looks good. You got to double check your input here. Press enter, divide by the square root of 5, and you get one huge number there. So okay, so let me write this out first. So 1 plus the square root of 5 divided by 2 to the 42nd power minus 1 minus the square root of 5 divided by 2 to the 42nd power divided by root 5. So the 42nd Fibonacci number is 267,914. Okay, sorry about that. So 267,914, 296. Let me check to see if this is right. So 267,914, 296. Yeah, 267,914,296. That's your 42nd Fibonacci number. All right. Now let's play with the calculator a little bit. This is a calc section here. You do this entirely on the calculator. So on this one here, let's clear it out. Let's take 1 plus the square root of 5. Oh, that's not correct. You gotta press the right buttons here. So 1 plus I'm having issues with my computer right at the moment. 1 plus the square root of 5. Let's see if I can keep this going. Enter. Divide by 2. Enter. Doing the step-by-step approach here. So that's the entire inside of the parentheses here. Now raise it to the 10th power. Yeah, my computer is going really slow here. Is that. Now I got to divide it by root 5. Okay, and now round it. Okay, so let me capture this here. Okay. So far my answer is 55.0036, but I said round it to the nearest whole number. Nearest whole number. So my answer is 55. Okay, so this is equal to 55. Okay, it's that right there. You got to round it to the nearest whole number. Maybe there's a correlation between F10 and the 10th Fibonacci number is 55. Look at that. Let me see. Holy cow, there is. Ooh. What's going on here? This is mysterious. This is like voodoo stuff. Okay, let's try it again. So 1 plus root 5. Okay, hit enter, divided by 2. Okay, take it to the 8th power. All right, divided by root 5. You get about 21. Round it to the nearest whole number here. All right, so let me capture this too. All right, so here it is. Now, when you take this answer and you round it to the nearest whole number, you get 21. That's why this one's 21. All right, you round it to the nearest whole number, and maybe that's some connection with F8. Maybe that's the 8th Fibonacci number, 21. Oops, 21. So let's go up to the top and see. Is the 8th Fibonacci number 21? And it is. Look at that. Holy cow. Maybe this is stuff's coming from Benet's formula. I don't know. What do you guys think? All right, let's do another one. 8. Okay, so F8. So given the 22nd and 25th numbers here, find the 23rd. So check this out. So you give an F22 and this F23, F24, F25. Okay, so let's say we're given these two, the 22nd and the 25th, right? And we want to find the 23rd. Well, what you do is you subtract and divide by 2 to get to the 23rd. Why is that? Well, let me see. Let me go back to basics. 1, 1, 2, 3, 5, 8. Let's suppose you know 8 and 2, and you have these 2 in the middle gaps. Okay, and let's suppose you're trying to find 3. What do you do with 8 and 2 to get to 3? Well, one way is to subtract 8 and 2 to get 6, and then take half. And notice that's 3. That always works. So you subtract and divide by 2. So what we want to do, F23 here, is equal to F25 minus F22 and divide by 2. So let's enter that in. It's 75,025. So 75,025 minus, all right, F22, which is 17,711. And then we're going to divide that by 2. And you get 28,657. Now, let's see if that works. If we add the 22nd term and the 23rd term, we should get the 24th term. Now, it's not asked for, but I'm going to use it to check my answer. So I'm going to add these two, and I get the 24th. And then I'm going to take the 24th and the 23rd to make sure I get the 25th term. If I do, I'm correct. Okay? So let's add our answer to the 22nd term. So we're going to add 1,711. There's my 24th term, which is 46,368. 46,368. Now I add these two, combine them. All right, and I get the 25th term. Let's see if I do. So I add 28,000, so plus 28,657. And look at that, I get the 25th number, so I know I'm right. Okay, so you just subtract and divide by 2. So let me capture that too. Okay, there's everything I just did on the calculator right there. Okay, so I found F23, the 23rd term, but I checked it by finding F24 and make sure I was able to get F25 right here. So this is F24 here, and this is F25 here. Okay, all right, let's keep going. Okay, so if you're given the 26th and the 27th terms, to get to the 25th, you subtract. So to go in the past, you subtract. To go in the future, the successive terms you add. So this is F27 minus F26. I just subtract these two numbers here. So let's do that. So let's press clear here. And so 196, 418 minus 121, 393. So there's my 25th one. So 75,025. We already knew that from above, right? Look at that. It's right up there. Okay, now to get in the future, we got to add these terms. So 196 plus, excuse me, let me start over. 196, 418, plus the 26th term, 121, 393. And you get the 28th term, so 317,811. Okay, now watch this. Now suppose you know two terms but don't know the one in the middle. So let me go to basics here. Here's the Fibonacci sequence. All right, we add 2 plus 3 to get 5. So if 2 plus 3 is 5, that must mean that 5 minus 2 equals 3. Right? So if 2 plus 3 equals 5, then 5 minus the second previous gives you the first previous. All right, so all you have to do is subtract these two. So this is F20 minus F18. So I subtract those two. So I get 6,765 minus 2,584. I get 4181. Now to go, once I know the 18th and let me see, 19th and 18th, I subtract to go back even further. So this is F19 minus F18. I already know F18, right? So I take 4181 here, subtract 2584. And I should be able to get the 17th term, which is 1597. Now, to get the one in the future, I got to take the 19th and the 20th and add them together. So F19 plus F20, I have to add those two. So 4181 plus F20, 6765. What's that? Let's figure it out. So 4181 plus 6765. 10,096. Excuse me, 10,946. Okay. So now let's continue here. Okay, so giving consecutive terms, find the one in the middle. We got to subtract these two again, as I said earlier. So let's subtract. Just clear your calculator and go for it. So we got 3,524,578 minus 1,346,296. And we subtract those and we get the one in the middle. So let's write that down. So here 2,178,000. 282. All right, that's the one in the middle. All right, so now how do you get the next term and the one previous? So here, let's do that again. Excuse me for a moment. Here we go. All right. So the 34th term. So I got to add F33 and F32 and F33, these two. So this is F32 plus F33. And what do we get? So here we go. So we got this result: 2,178,282 plus 3,524,578. Make sure you put the right numbers in, and you get the 34th Fibonacci number. Let me see here. 34th. I don't think I entered it in correctly here, so let me see. Let me double check. Okay, I gotta fix my mistake. I got a mistake here on F32, so I'm gonna redo this. So let me double check my work here. So I'm gonna enter in the 33rd one here. I must have put in the number in wrong. So 3,524,578. All right, minus the one above it. Just checking here. So minus 1,346,000. 269. Let's see if I get the right number here. So the 32nd number, yeah, now we're looking good. So 2,178,000. All right, 309. There we go. Now I have to take that and add it to F33. So plus F33, which is 3,524,578. And we should get the 34th number there. Aha, we got it right now. Okay, so 5702887. There we go. 5,702,887. There we go. Now the 30th number. So what's that? Well, that's F 32 minus F31. All right, so let's write that out. So okay, so here we go. So 2,178,309. That's F32. Subtract the one before it. All right, which is F31. So minus F31. The hardest part about this, guys, is just entering the darn number in correctly. Okay, that's the hardest part. All right, and you get the 30th number here, which happens to be 832,000. All right, and 40. That's it. Okay, moving on. Okay, okay, that was a struggle. So, which Fibonacci numbers add up to 52? Okay, so let's go up to the top again. So 52. Let me see. How about what about 34? And I don't know. Let's see. 34 and 13. That's 47 and 5. So 34, 13, and 5. Let's try that. 34, 13, 5. So that's 30, that's 47 plus 5 more is 52. Okay, there we go. And then how about 34 plus 13 plus 5 plus 1? And then 107, ooh, I don't know. Gotta look at the numbers here. So how about 89 and, let's see, 89 and 21, that's 110. That's too high. So 89 and 13, that's 90. Okay, 89, 13, and 5 maybe. 89, 13, and 5. 89, 13, and 5. Let's try it. So 89 plus 13 plus 5. 107. There we go. So how about 89 plus 13 plus 5, and then to get to 112, I got to add 5 more. So, and they got to be distinct. So plus 3 plus 2. All right. They must all be different. Okay, must be distinct. Different. Okay, that's what that means. Okay, what is the recursive formula for the Fibonacci sequence? Okay, so f sub n is equal to the sum of the two previous ones. You already know that. Just look at your notes. All right, next one, find the next three terms. Okay, so here we go. This is review. So your seed, all right, is 1. So A2 is 2 times A1, all right, plus 1, which is 2 plus 1 is 3. And the next one, 2 times 3 plus 1, that's 6 plus 1, or 7. And then it's 2 times 7 plus 1, or 15. All right, this right here is the previous term. So you got to remember that. That means previous. All right, one more time. So again, it's the previous term plus 2 divided by 2. So A2 is A1. So I got to start here, right? So 20 plus 2 divided by 2. 22 divided by 2 is 11. Then I take that, 11 plus 2 divided by 2 is 13 halves, or 6.5. And then I take that, 6.5 plus 2 divided by 2 is 8.5 divided by 2, 4.25. Okay, on proportions, you cross multiply. Again, I threw in some review because this is, a comprehensive quiz. So let's cross multiply. We're going to take this product and set it equal to this product here. So x times x minus 1 is equal to 1. You have x squared minus x equals 1. After subtracting 1, you get x squared minus x minus 1 equals 0. A is 1, B is negative 1, C is negative 1. You've seen this before. And after you use the quadratic formula, x is equal to 1 plus or minus the square root of 5 divided by 2. Okay, now on these, you want to round to the nearest thousands, because it says so, okay? It's a calculator exercise, so you use your calculator. So you clear it out, and you go 1 plus root 5. Okay, it'd help if you put the numbers in correctly, So 1 plus the square root of 5 divided by 2 to the power of 12. And then you round it, all right? The fourth digit's 8, so it's 321.997. Okay, nearest thousands. Okay, now let's do it again, but this time let's take it to the 15th power. But let's include a minus sign. So 1 minus the square root of 5 divided by 2 raised to the 15th power. Okay, now this is scientific notation here, so I have to move the decimal left 4 places. So I need 3 zeros as placeholders. So it's negative 0.000733. So negative 0.000731, which approximately equals to negative 0.001. Okay, when you round to the nearest thousands. Okay, dokie. Okay, next one is 1 plus the square root of 5 divided by 2 raised to the 25th power. 167,761. Okay. Next one here, round to the nearest whole number. So let's highlight that, nearest whole number. Calculator problems again. So here we go. Let's clear it out. We have 1 plus the square root of 5. Okay. Divided by 2 raised to the 4th power. Divided by root 5. And you have to round that. Okay. So that's rounded to 3. So 3 here. And notice the power here. If the power is 4. And notice that this is a Fibonacci number. This is the 4th Fibonacci number. This is equal to F4. And notice this too. Oh gosh, maybe there's a connection there. I don't know. So when the power is 5, let's figure out what happens. Let's redo it. So let's do the whole thing on the calculator this time. Double up on the left. All right, 1 plus the square root of 5. Get out of the root. Close it off, divide by 2. Close it off, take it to the 5th power. There's that whole thing done on the calculator. Divide by root 5. All right, and round it right there. That's 5. So that's 5. And guess what? That's the 5th Fibonacci number. That's F5. Maybe there's a connection there. I don't know, something crazy is going on here. What's the monkey business going on? When you raise it to the 6th power, what are you going to get? F6? I don't know. Let's find out. So let's take 1 plus square root of 5. All right, divided by 2. And raise it to the 6th. You get 17.94 divided by square root of 5. Not done yet. All right, and you get about 8, right? Rounded to this whole number. Maybe that's F6. I don't know. So let's find out. Let's go up to the top. Holy cow, that's F6. Look at that. Maybe there's a connection there. Maybe this crazy business actually means something. All right, almost done. Let's find the next three terms. So you add these two to get 5, and then add these two to get 8. So 5 plus 8 is 13, and 8 plus 13 is 21, and 21 plus 13 is 34. It's the Fibonacci numbers starting at 2. Okay? And look at this. Look at this. Look at this. Look at this. Okay? 2 squared is 4, 3 squared is 9, 5 squared is 25, 8 squared is 64, 13 squared is 169. All right, you got to square it. 21 squared, don't know what that is. That's over 400. So just use your calculator, right? All right, 441. And then 34 squared, this is 13 squared, 21 squared, 34 squared. What's that? It's over 900. It's over 1,000, I think. 1156. Okay, next one. 2 plus 2 is 4. 2 plus 4 is 6. 4 plus 6 is 10, and 6 plus 10 is 16. So, and then you get 26, and then 42. Same thing here. 3 plus 3 is 6. 3 plus 6 is 9. 6 plus 9 is 15. 9 plus 15 is 24. 15 plus 24 is 39. 24 and 39 is 63. Okay? Okay. Last few. Simplify. Review problems. Divide them all by 4. So 1 plus 2 rad 3, all divided by 3. Divide by 5. 3 minus 5 rad 2, all divided by 2. Simplify first. So this becomes 8 minus 2 rad 2 divided by 12. So we simplify the root. Simplify first, and then you go for it. And so you divide them all by 2. You get 4 minus rad 2 divided by 6. Okay? All right. Well, that's Mr. Ainsworth here. I'm done. I'm tired. I'm going to go home and relax. Okay? You guys study, though, because you're in school. Okay? And I'll see you tomorrow on test day.